Hello, everybody. Today is January 14th, 25. Today's another day of Leetcode for my daily vlog-ish stuff. I hope you guys are enjoying the content. I'm actually kind of surprised I haven't hit a point where I haven't failed something. I mean, I hit a point where I had a hint, right? But I haven't actually failed a question yet. It's coming, don't worry, because normally I fail lots of questions, especially in the competitions, especially seeing how hard they've been. But yeah, we're just strolling along. So we're gonna go ahead and warm up our fingers. So let's get started. Okay, it's about normal typing speed. Let's see what our problem of the day is. Minimize XOR. Okay, I've not done this problem yet. Okay, let's do this. 24, 29, minimize XOR. Given two positive integers, num1 and num2, find the positive integer x such that x has the same number of set bits as num2. The value x XOR num1 is minimal. What does that mean? Does that mean that's the smallest value for x? Note that XOR is the bit, obviously. Return the integer x. The test cases are generated such that x is uniquely determined. The number of set bits of an integer is number of ones, obviously. Okay, so the number of ones, the number of active bits. So we're looking for something that has the same number of set bits as num2. Hmm. So integer 3 has the same number of set bits as num2. And the value 3 XOR 3 equals 0. Because it deselects each bit, making it the smallest value possible. So we're looking for a value that's something. Was this like a binary search? If we do a binary search on bits, Well, we are obviously know the number of bits for num2, right? It's basically given as an integer. And then we need to minimize. Okay, so how do you do a binary search on a binary value? Oh yeah, 10 to the 9. This is definitely binary search. It's like binary search equals bit manipulation. So this can be 1 to 10 to the 9. We know the number of set bits has to be this. And we know that we want to minimize this value. Okay, so if I remember right, pop count will tell us the number of bits, right? Oof, I can't remember. I think it might be something like this. Was it this? Let's see. Did you mean that? Quite possibly. Okay, so we printed 2, and 5 is consisted of 1 plus 4, so that's 2 bits. Yeah. Which means that num1 is also 2 bits, which we can just check. Yes. Okay, so this is the number of active bits. Pop count. So I don't have any brain fog. So we want to store this value. Let's go int active bits. It does return an integer. Yeah. Okay. So we have our active bits here. This is the number of bits that is required for the value. Okay, so we just need now to check this number of active bits from whatever the first is to the second one. Or to the, no, because they all have the same number of bits. Right? Okay. So if we have 3 and 5 as our values, 3 is 2 plus 1, so it's 1, 1. And 5 is 4 plus 1. So 4, 2, 1. All right. Okay, so we have 2 bits. So this so first value identifies bits. Or no, second value. Okay. Sorry. If you guys couldn't hear me before, I'm sorry, the mic was tilted. The thing is, I don't exactly know how to do a binary search on only things that have bits of this count. This is actually a first for me. I don't know how to do this. I get the idea, I just don't know how to do it bitwise, so logically. Hmm. At 10 to the 9, I don't think it's would be a good idea to just check all of them, all the values. X. Hmm. Maybe one of the hints will tell me. Alright, let's go to the topics first. Yeah, we already knew that. Oh my goodness. If we have active bit count and we're trying to find the smallest value size for num1, 3 would make the value 2. The reason we chose 3 is because it has to have 2 bits. The 2 largest bits in the value of num1. Or in this case, let's see, 1 and 2, I'm sorry, 12 is 2 bits. So we need a value with 2 bits, which is 3. So we just activate the first number of bits. Oh my goodness. Hold on. So if you have 2, you just want the first 2 bits, right? And then that's the value. Does it not matter? Does num1 not matter at all? I know this is the smallest value you can get with the 2 bits. Right. No, hold on. I did that wrong. The only reason I'm doing it this way okay. Actually, I see 2 phases here. First, we want to go from largest to smallest active bits in nums1. This is not binary search, actually. But how would I do that? So we want to fill in the largest value, which is here, and then just increase the XOR going left to right. But it's backwards. So how do we get the highest active bit? Wait. We don't need to do that. We just need the number. Hold on. Okay, so yeah, okay. So if we just set the value to x and then get the remainder, right? So we set 1 to here, and then there's 1 bit remaining. Unless the value is greater, then you have to deactivate bits. But you can do that from smallest to greatest, not greatest to smallest, right? So, not active bits. Int remainder. Okay, so if we have num1, so there, say if we have 1 bit versus 2 bits, um, okay, if remainder if they have the same bits, right, then just return num1. If it's a remainder 0 is less than 0, hold on, let me think this through. For the remainder less than 0, this value would have to be smaller than this value. It has oh no, this value would have to have less bits than this value, which means we'd have to deactivate bits, right? And last case scenario, when the remainder is greater than 0. So in this case, the 12 or 2 minus 1 is 1 bit. We need to activate bits. Right. So this one I think is going to be simpler than the deactivate bits. Right. So let's go ahead and do the activate bits first. Okay, so in this case, we want to remove, or I'm sorry, we want to activate bits going from right to left until we're out of remainder. So while remainder we're going to go, okay, we're going to shift I. Well, actually, we can do this. For int I equals 0, I is less than remainder. Right. Okay, and now we want to shift I, which we already have, left. So we're going to go, we want to do a value of I, or no, we want to shift 1 over I times, right? And we want to XOR this with nums 1. And we only want to do that if wait, hold on, I did this wrong. Yeah, I set this up wrong. Hold on. While remainder. Yeah. So while or no, if we and it, right? We go okay. I want the opposite of this. Okay, shift this to the left and it to X. If they are both set to 1, this is going to give me a 1. Oh, no, like this. Right? And the second that this is not a 1, then we're going to set it to 1. And then we're going to go remainder minus minus. Right? So we're going to go X, XOR equal this bit. Right. Get rid of this. And then this value, when done, should be done like this, right? Now, this should work for this second example. Whoops, I did not mean to refresh. Run. Return X. Oh. Yeah, so this works for this. Okay, so now we need, if the remainder is less than 0, we need to activate or deactivate bits, right? But we have to deactivate bits from greatest to smallest. My question is, how do we know what the greatest bit is? I don't know if size would help. I could always just get the maximum index, keep going over and over again until all the remainder is done. Now, I'm pretty sure a while loop continues to run as long as it's not 0, right? So we're just going to do a loop. We're just going to increase the remainder. For each one, we're going to find the, what was it, the biggest indexed value? I almost want to turn this into a bit set or a string and then reverse it. That would make it easier. So it's only going to be a maximum of, what's it, 32 bits for an int. I could just redo the int. For instance, we know the number of active bits that we have. If it's a negative number that's different for the remainder, and we need to get rid of the furthest left values, right? Then what we really need to do is we need to set the bits on the right side instead of the left side. Yeah, so if we have remainder, and then we have a remainder of bits from left, and then we have on the left side, and then we have the number of bits on the right side that we're keeping, right? How do we get the number of bits that we're keeping versus the number of bits that are left? Right? Because if we can just get this value instead of this value, right? We could just take an int and set bits to nums until we reach remainder, which would be a lot easier than trying to remove them from the end, right? Now hold on. Okay, so we know that whatever value we are going to choose has to have hold on. Number of bits we're keeping. Keeping this number of bits. Wouldn't we just keep this number of bits from num1? Because if we have to remove them, there's too many, right? So we just need to activate bits from num1 up till this point. So instead of remainder, we just need active bits, right? And then we can just go 1. Okay. And then we just want to set the number of bits from X. Okay. Or from num1. And then we can set it to X, right? Or we can just say, if this is true, we can just go X equals 0. Because we still have num1, right? Okay, and then we need a for loop. Was it? No. That's what active bits are for. I feel like I need an index. Let's see, we set a bit. Okay. So we need set next available bit, right? From right to left. While this is where an index comes into play. 1 shift and x. Okay, so while one. Oh, did I already do this? Activate bits from smallest to largest. I did. Oops. It's the same thing. Except the difference is the remainder versus the... Oh, and I'm starting with x is equal to 0 instead of x is equal to nums 1. Right. Would this work? Okay, so we need a test case where this value or this number of bits is greater than this number of bits, right? Or no, I'm sorry. This number of bits is greater than this number of bits. So let's go, instead of this, we're going to go 12 and 1. Right. We're getting 8. Okay, if this is 1100, there's 2 bits. Or there's 1 bit here. 2 bits. How is this 8? Oh. Oh, wait, no, that's wrong. Hold on. Check my example. So 12 and 1. We're just flipping them. Okay, so nums2, number of bits required for x. So 1 bit, right? And then this is the thing that we need to minimize. Right? Wait. I outputted 1. Oh, I did this wrong. Hold on. While is too large for 32 incher. Hold on. But we don't want to reset I, right? Hold on. Okay, so I got 4 here. But to minimize, you have to XOR the largest bit. Hmm. While x is less than no, that's not what we need to do. We have an index, largest I. If we say largest I, we're going to say largest value. Well, largest value no. We need the index, right? We could just go left until the value is greater than the set bit or the set value. And that'll tell us the index. Well, largest, right? The value has to be minimized. Nums1 has to be minimized. So we need the largest bit of nums1. While largest is less than nums1. Can't I just do something like largest times largest? If I set largest to 1 to start, right? Oh, that's just going to be 1 times 1 then. That's not going to work. Largest plus equals. It's squared, right? Oh, no. Sorry. Shift 1. So just shift the value over. Okay. And while we're doing that, we can keep a index. Right. This will tell me how many times we've shifted over. Okay. So we shift over, we get the index until it's greater than 1. Then we back off by 1. Okay. Okay, and starting from largest I, going to the right, to the left, we can say while this equals 0 from nums1. So instead of I, we're going to go largest I. Right? Okay, so this needs to be 0. that backs off. This sets the bit, right? Minus the active bits. And go to the next one, right? This is for X. If this was the case, this X needs to be nums 1, right? So we're using the largest index as our index. And numbing it to X. Is it nums 1? Is it num 1? Did I get that messed up? Okay. 13. What did I do? Is it because of this, maybe? Hold on. It's still giving me 13. Let's see. The next bit after 8 is 16. We back off 1, it's 8. So how am I getting 13? Four. Let's see. 4. 0, 1, 2, 3. 4. We subtract 1. It's this bit. So this should be bit 3. Okay, largest index is bit 3. Really? Let's see. Is this not right? It's 14. What am I doing? We're shifting to left. Changing it to X. If it's 1 and 1, if it's not 1 and 1, go down. Right. And then when it goes down, it shifts the bit, or it flips the bit. Once you found a 1, then largest index should still be in the same spot as it did previously. Then it's going to have to keep going down until it finds the next one. 4. I'm outputting 4. If I XOR, so there should be 1 bit, right? How am I getting 8? Has the same number of set bits as nums2. Okay, there's 1 set bit, right? And then we have 12 as nums1. Is minimal. One, 2, 4, 8. Wait. Why am I getting 4? I should be setting this bit. X. We found the largest bit. X should be 0. Right? We want to set the bit at 0 to 1. Hold on. Num1, if this is a 1, we're looking for the first 1 bit, right? So if this index is the largest index and num1 is a 1, we want to set x index to here. Right. And once this bit is set to 1, we want to go down 1. Either way. Right. So x, assuming here, which means we might not want to delete this. Whoa. Shift over to the largest index is 3. If you shift 1 over 3 times, you get 8. 8 and num1. So this should be 1. This should be not. Am I doing that backwards? There we go. Okay. Let's go ahead and add a test case. 1, 2. Let's go ahead and see if the reverse works. Okay, so we have one that's greater than the others are greater than the other, and if they're equal. So I think this... The only thing I'm concerned about is very high values. But for now, let's go ahead and check if this works. Ha ha! Hooray! Victory! Alright. Unfortunately, I had to look at the topic, which didn't help me at all. I already knew the topic. The hint is what gave me an idea to how to do, though. It was a good hint. It didn't really spoil the problem. What was it? I only seen hint 1, I think. Yeah, I seen hint 1. It's hint 2 if there's still... Anyway, I gotta go. I have a phone call. Thank you for the problem, and I hope you guys have a wonderful day. Peace.